So we'll look now at systems of equations where potentially I have something beyond just a linear term. So before we saw how to look at the solutions to systems involving two lines. Where do they intersect? These were both first-order polynomials. It is possible in the clip that you'll see something of higher order, that you might see a linear equation combined with a quadratic. So we're going to talk just a little bit about that situation. So here's an example. Again, I have this brace here, which means I want them to be solved simultaneously. But here, this is linear, but this is quadratic. So you might think to yourself, well, how do I generalize the techniques we just had to this case? Well, it's actually kind of clever. We still have the property that y is equal to some linear thing, and y is also equal to some quadratic thing. So I can set those two expressions for y equal to each other. And lo and behold, what I end up with is a quadratic equation. I know how to solve that with the quadratic formula. So let's look at an example of exactly how to do this. So we'll solve x squared plus 2x plus 1 is equal to y, and also minus 2x plus 3 is equal to y. So right, I have a quadratic term and a linear term. How do I solve this? Well, I'll combine these together to get x squared plus 2x plus 1 equals minus 2x plus 3. How do I get this? Well, they're both equal to y, so I can set them equal to each other. And then I'll rearrange things just a little bit, and I'll get that x squared plus 4x minus 2 is equal to 0. How can I solve this? Well, I can always use the quadratic formula. So x is equal to, let's see, a is 1, b is 4, c is negative 2. So I get negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 2. Times negative 2 divided by 2 times 1. So negative 4 plus or minus the square root of 16 plus 8 divided by 2. So negative 2 plus or minus square root of 24 over 2. And this can be simplified to 2 plus or minus the square root of 6. And for here, we just notice that square root of 24 over 2 is square root of 4 times square root of 6 over 2, so just square root of 6. So I get my two solutions in terms of x, and then I can, of course, plug back in to get y. So for example, y is equal to negative 2 times negative 2 plus or minus square root of 6 plus 3. So what's my picture look like here geometrically? So my parabola might look something like this. My line looks something maybe, maybe more or less like that, something of this nature. So I see I have two places where they intersect, which of course agrees with what the solution I got from the quadratic formula was. So this type of problem is likely to appear on the CLEP, but not in great depth. So spend a little bit of time on it, and I think you'll see that all you really have to do is basically use the quadratic formula in this sort of broader sense, where if I have a linear equation and a quadratic equation, I can set those equal to each other and take all the terms to one side and get a quadratic function equals 0. And I know exactly how to solve that with the quadratic formula.